Hi viewers, today I'm here with an interesting topic, trigonometry. The word trigonometric means measures of triangles. We shall be dealing with the relations of the sides and angles of right angle triangle, concept of perpendicular, base and hypotenuse of a right angle triangle will be discussed here. For any acute angle, which is known as angle of reference in a right angle triangle, ABC, the side opposite to the acute angle, say if you take the angle B as angle of reference, let me call it as theta, the side opposite to B will be called perpendicular, or it is also called as opposite. And the side adjacent to the angle of reference, that is B, is called adjacent, or it is also called as base. And the side opposite to right angle is called hypotenuse. So in this, AC is the opposite, BC is the adjacent, and AB is the hypotenuse for the angle of reference in a right angle triangle, theta. Let us do this example. That is a triangle LMN right angled at M. For the angle of reference, two acute angles L and N. For the angle of reference L, what will be the hypotenuse? The hypotenuse is always Ln. Opposite to the angle of reference L is Mn, and adjacent to the angle of reference L is Ln. Same for the angle of reference N, we can say hypotenuse will also be always be the same in a right angle triangle, the side opposite to 90 degree. It is Ln. Opposite will be Lm, and adjacent will be Mn. Similarly, for this triangle, we can say the hypotenuse as PR, opposite as, with reference P, opposite will be QR, and adjacent is PQ. Similarly, for angle R, hypotenuse remains the same, PR, opposite will be PQ, and adjacent will be QR. So this is the main concept which you need to understand to find the angle of reference. What is the opposite and the adjacent? So based on that, we will be deriving the trigonometrical ratios. Okay. The ratio between the lengths of a pair of two sides of a right angle triangle is called the trigonometrical ratios. The three sides of a right angle triangle gives 6 trigonometrical ratios. They are sine, cosine, tangent, cotangent, secant, and cosecant. In short, they can be called as sine, cos, tan, cot, sec, cosec. So these are the 6 trigonometrical ratios which are derived from 3 sides of a right angle triangle. Say for example, in a right angle triangle LMN, right angled at M, sine is always opposite over hypotenuse. Okay. Now, here for which angle of reference you need to mention here. Say for example, I'm writing the angle of reference. You can refer the angle with various letters, that is theta, phi, psi, alpha, beta, etc. Right? So, okay, now angle N is referred as theta, and we are going to write the value of sine theta as sine is opposite upon hypotenuse. Now, what is opposite to this angle of reference? LM will be LM upon LN. Cos is said as adjacent upon hypotenuse. Now, what will be cos theta? Cos theta will be adjacent to theta is Mn and the hypotenuse is Ln. Similarly, tan is opposite over adjacent. So when we derive the ratio of tan theta, we'll get the two sides as Lm over Mn. So these are the 3 things which you need to understand: sine, cos, and tan. Say for example, ABC is a triangle, right angled at B. AB is given as 4 centimeter, BC is given as 3 centimeter. To find the hypotenuse, use Pythagoras theorem. What is the Pythagoras theorem? AC squared is equal to AB squared plus BC squared. AB is 4, so 4 squared is 16. BC is 3, so 3 squared is 9, so which will be 25. So AC will be equal to root 25, which will be 5. So we got the hypotenuse as 5 centimeter. Now you need to find sine A. Sine A is opposite upon hypotenuse. Opposite, the opposite of A is BC and hypotenuse is AC, which is nothing but 3 by 5. Similarly, cos is adjacent upon hypotenuse, which is adjacent is AB over AC, which will be 4 upon 5. Similarly, tan is opposite upon adjacent. Opposite is BC over AB, which can be written as 3 by 4. So we got the values of all sine, cos and tan. We are now going to see the values here of with a different angle of reference. Another acute angle which you have, that is C. So what will be sine C, cos C and tan C? Sine C, sine opposite upon hypotenuse. The opposite of C is AB upon AC, which will be 4 by 5. This time, sine C, you can observe, sine C is equal to cos A. And cos C will be equal to sine A, right? So cos C is adjacent upon hypotenuse. Adjacent of C is BC. BC upon AC, which will be 3 by 5. And here, opposite upon adjacent, which will be, opposite is AB and over BC. So 4 by. So we have derived sine, cos and tan. Now the remaining three trigonometrical ratios we are going to see. For remembering the formula for sine, cos and tan, so ka toa. SCT indicates sine, cos, tan. O is for opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So if you remember ka toa, you can easily frame the ratios of sine, cos, tan. Okay. The remaining trigonometrical ratios are cosec, sec and cot. Cosec A, sec A and cot A. Cosec is the reciprocal of sine. So we can say that it is hypotenuse upon opposite, which is nothing but 5 by 3. Sec is hypotenuse over adjacent, which will be 5 by 4. And cot is opposite, adjacent over opposite, which will be 4 by. So if you remember sine, cos, tan, we can derive cosec, sec and cot. Cosec is the reciprocal of sine, sec is the reciprocal of cos, and cot is the reciprocal of tan. And it is vice versa. That is, sine is the reciprocal of cosec, cos is the reciprocal of sec, tan is the reciprocal of cot. Let us do this question. In this figure given, ABC is a right angle triangle, right angle at B. BC is 5 centimeter and AC minus AB is given as 1 centimeter. Okay. So let me take this AB as X. So AC will be 1 plus X. Using Pythagoras theorem, you can say that 1 plus X whole square is equal to X square plus 5 square. So opening the bracket, you'll get 1 plus 2x plus x square is equal to x square plus 25 X squared on both the sides will get cancelled. 2x is equal to 24, x is equal to 12. So we got the side as AB as 12 and AC as 13. Right? Okay. Now we need to find the value of cosec A and cos A. Cosec A. So A is the angle of reference. Cosec, the formula is hypotenuse upon opposite. Reciprocal of sine. Okay. Hypotenuse is AC and opposite is BC. So you'll get 13 by 5. 13 by 5 can be written as 2.6. Now cos is adjacent over hypotenuse. Adjacent is 12 and hypotenuse is 13. So 12 by 13 is cos A. Cosec A is 2.6. I'm going to discuss about the square relations of trigonometrical ratios. Take a triangle, right angled at M, LMN is a triangle, right angled at M. Let us write the Pythagoras theorem of this. LM square plus MN square is equal to LN square. Dividing both sides by ln squared, we get lm squared upon ln squared plus mn squared upon ln squared is equal to ln squared upon ln squared. So if we do so, lm upon ln whole square plus mn upon ln whole square is equal to 1. What is lm upon ln with respect to the angle of reference L? Lm is adjacent over ln is hypotenuse whole square plus mn is opposite upon hypotenuse whole square. Remember, so ka toa. So ka toa. Sine is opposite upon adjacent, hypotenuse. Cos is adjacent upon hypotenuse. So adjacent upon hypotenuse is cos theta. If I take this angle as theta, this will be cos theta. Cos theta whole squared will become cos squared theta plus opposite upon hypotenuse is sine theta. So it becomes sine squared theta, which is equal to 1. So the square relations of cos and sine is 1. So the addition of cos square theta plus sine square theta gives you 1. Similarly, we can prove other relations as well. Now dividing both sides by Lm squared. Lm squared upon Lm squared plus Mn squared upon Lm squared is equal to Ln squared upon Lm squared. Lm squared upon Lm squared will be 1 plus this can be written as Mn upon Lm whole square is equal to Ln upon Lm whole square. With respect to theta, Mn is opposite upon Lm is adjacent whole square. Ln is hypotenuse over Lm is adjacent whole square. So now recall the trigonometrical values ratios. 1 plus Opposite upon adjacent is nothing but tan, so which can be written as tan square theta is equal to adjacent upon hypotenuse is cos. Hypotenuse upon adjacent will be sec. Sec square theta. Now if we take the tan square there, you can say sec square theta minus tan square theta is equal to 1. Similarly, dividing both sides by mn square, we get lm upon mn the whole square plus 1 is equal to ln upon mn whole square. Lm with respect to theta is adjacent and mn is opposite whole square plus 1 is equal to ln is hypotenuse and mn is opposite whole square. Now seeing this so-called to you can tell if opposite upon adjacent is tan, what will be adjacent upon opposite? It is cot. Cot square theta plus 1 is equal to opposite upon hypotenuse is sine. Hypotenuse upon opposite will be cosec. So cosec square theta. Now bringing this cot square theta to the side, you'll get cosec square theta minus cot square theta is equal to 1. So the relations which we saw, the square relations, you have cosec square theta minus cot square theta is equal to 1. Sec square theta minus tan square theta is equal to 1. Cos square theta plus sin square theta is equal to 1. So if you remember the square relation, you can solve many questions in trigonometrical ratios. Let us summarize whatever we learned. Sin theta, sin is equal to opposite upon hypotenuse. Cos is equal to adjacent upon hypotenuse. Tan is equal to opposite upon adjacent. If we take cosec, cosec is hypotenuse upon opposite. Sec is hypotenuse upon adjacent. Cot is adjacent upon opposite. These are the trigonometrical ratios. Trigonometrical ratios. Now, if we see the reciprocal relations of the trigonometrical ratios, reciprocal relations are for sine, sine is equal to 1 by cosec. Cosec is equal to 1 by sine. Cos is equal to 1 by sec. Sec is equal to 1 by cos. Tan is equal to 1 by cot. And cot is equal to 1 by tan. Next, quotient relation. If we divide two trigonometrical ratios, we get the third ratio. That is, if we divide sine and cos, we get tan. tan is equal to sine over cos. You can check it out. Tan is opposite upon adjacent. The sine is opposite upon hypotenuse and cos is adjacent upon hypotenuse. If we divide, you'll get opposite upon adjacent. Similarly, cot is cos upon sine. So now the last relations which we have seen is square relations. Square relations are cos square theta plus sine square theta is equal to 1. Similarly, sec square theta minus tan square theta is equal to 1. Cosec square theta minus cot square theta is equal to 1. This is the detailed introduction about trigonometrical ratios. Now, in the coming episodes, we will be seeing varieties of questions solved using the trigonometrical ratios. Watch this video till the end and stay tuned for my next video. Until then, bye.